So without any further ado, Caroline is a principal at a Toronto area school and has had, I believe, over 20 years of experience in bringing math excellence, not just in the classroom, but outside. And she's going to be speaking to that a little bit today.
Great, thanks, Charles. You know, in our group one, we had some really interesting discussions, mostly I'd say about high school, which I'll be focusing more on elementary, but it's really interesting because as my role as an instructional leader, I had worked both with elementary and secondary, but most of my work happened to be in the transition years of 7, 8, 9, and bridging the two panels together was always and still is always a challenge. And so it's something that, you know, I think as a board, as a province, we still try to look at. So other things that came up too is, you know, how is it that the secondary curriculum, and that's where we see a lot of the kids really struggling. What happens when they do that shift from elementary to secondary? And we always want to try to avoid the blame, and, you know, and always pass, you know, kind of pass the blame down to the panel below. And my husband, who teaches at U of T as well, you know, the same thing is like, what are the high schools doing? Because the kids are not prepared when they get to secondary. So we want to try to avoid all of that and try to help everybody. And it also comes down to what we also talked about was a lack of specialists, particularly at the elementary. And so there is part of it in terms of what is the role of the teacher and how much should they know. And then what Amy had said, it's about that relationship. And when I go through my presentation, a lot of it is about building that partnership and trying to educate both the parents and the teachers at the same time by doing some of the things that we do. So I'm just going to share my screen and hope this all works out well. And as I'm doing that, let me just see, okay, so. Okay. Okay, so hopefully you're seeing just the screen, not everything else.
We see your speaker's notes this time, Caroline.
I knew it. Okay, so what I'm going to do, I'm just going to share it, but I've got a backup. Okay, so let me redo this again. It's okay. Okay. All right, so now you should just see my presentation, which is okay too. All right. Okay, so, you know, in the different roles that I've had, you know, it always really boggled my mind as to how can we get parents involved. And I remember when I was a young rookie and I was working with teachers, I always wondered, you know, why is it that the teachers weren't understanding what I was doing when I was doing my workshops? Because if they just copied everything that I did, everything should be fine. And then I soon realized that that wasn't going to be the case, and that every teacher is different. Everyone has their own strengths in terms of their understanding of mathematics. The range varied quite a bit. So I had to think of different ways as to how I was going to engage teachers at that point. And then when I started working with even the teacher candidates at OISE, it was the same thing. I had students who really was afraid to be elementary teachers because of the math and didn't really think that they were responsible for that, to getting qualified as a teacher. And then working as an administrator, I realized that parents didn't have the time to learn it. They didn't have the time to go through the curriculum. They didn't even know where the curriculum was. All they knew was that there were textbooks and that there were teachers that were going to be teaching it to them, and it was their responsibility. So I had to do a lot of changing as a principal as to how are we going to really get parents involved. And depending on the communities, and Toronto has a very, very diverse group of students and communities. Sometimes engagement doesn't happen. We can plan these amazing things to get everyone involved, but we find that the parents either can't make it because they're holding 2 jobs and they can't get there at night, or they have 4 kids and that's their time where they have dinner, or they're very involved in hockey and so on. So we had to look at kind of different things as to how to do that. And we really wanted to make sure that, sorry, I'm just gonna move some of my things over here for a moment. We wanted to really have better communication between the school and the parents, and make sure that we all have common goals. And I would say probably one of the, I guess, the most of my emails or phone calls that I get are parents saying, I don't understand why they get this, why they got this mark, or my child doesn't understand anything that's going on. And it's really that they're not upset that there's no learning happening. It's usually because there's miscommunication as to what the goals of the math curriculum is. So part of my role as an administrator is to help build that partnership and to help with that understanding. So when we look at the students, one of the things that we want to do is we want to try to prevent that math anxiety. And they have anxiety because they don't understand what's going on. When they look at things, it's not the way that maybe they are, that they learn best. When we look at, even just at home, the parent might say, oh yeah, I wasn't very good at math, so this is why my child's not very good at math. So it's like this hereditary trait that goes down. And we also get a lot of the parents who have been raised in a math culture where it might have been very rote learning. It's very linear, and not a whole lot of explaining why you get things, but just memorizing the rules. So that's thinking that we need to kind of change and adjust when we're working with our students. Then we also have our parents, and as I mentioned, they consider the old math is what they knew and how they were taught, but then the new math are completely foreign to them, and they don't understand what the purpose is and why is it that my child has to learn it. They already know how to add, they already know how to multiply because they've memorized their timetables from 12 times 12. But you give them 12 times 13 and then it becomes a kerfuffle. So what are the things that we can do to help educate our parents? And especially those of us who are in math, it's not just about learning the math, it's about really loving the math and enjoying the math and seeing how math is connected to different things. And in our group 1, we were talking about, in this COVID situation, how many are actually looking at those graphs and understanding what the data means. And I try to share some of that data at the elementary. My school is only a K-5. So for me, working mostly with older students, it's a challenge sometimes to try to break down the relevant math, but make it really interesting to our community. So if I share a lot of that with my own community through my newsletters and adding the math here and there, they will see the relevance as well. And, then there's also a shift in terms of who is responsible and accountable. And, before, the thinking was that, students have to study. If they get low marks, it's because they didn't study enough. But now, right away, the blame goes to the teachers. And that's where I have to be a filter sometimes, and or padding as well, to try to break that down, because a lot of teachers get really stressed out about not being able to, I would say, even defend their own programming. And as a principal, I always tell my staff, I need to know everything. I need to know how you're teaching. I need to know what you're doing so that I can advocate for you. And then that's a door as well for me to say, okay, I think you might need some help in this. Let's work on that. And, the parents, I think, and I would say lately, and, now that we're doing online, their notion of math is very different. And it's really interesting to see how this is going to pan out by the end of June. And then we have those teachers who are really, really gung-ho and are really looking at questioning. And that's part of what I'm going to be talking about, is just having parents understand what kind of questions we're asking. But, when questions go home and parents don't understand what that means, they don't see the relevance, and then they also feel helpless. And then there's our teachers. So when we're looking at our partnership, we want to be able to help all parties. And with our teachers, we really want them to build comfort and confidence in their own programs. And if they're teaching, something that they're not that comfortable about, they will go and check the answer book. And we all know that we have those really bright students who don't have the answer book answer. And it stumps teachers, and it puts them in a position of not knowing and really feeling, bad, and then very defensive about their own teaching. So we need to build teacher efficacy and confidence, and they need to be confident about what their own programming is. And we've had this problem in terms of building the expertise at the elementary level. And whenever when I was at OISE teaching the JI program, there were a lot of JIs who were still thinking, maybe I'll go into secondary. And I felt it was my job there at OISE to try to keep them in elementary, because we do need to have more that have that deeper understanding so that they can better connect it to authentic learning that we really need to have more so in the classroom. And then we also need teachers to know how to be able to communicate to the parents. And I think that's a difficult thing for a lot of teachers. And unless the teachers understand why we're giving these kinds of questions, why we're giving these type of tasks, it makes it really hard for them. So our goal is not just to teach the parents to have them be experts. We really want them to be facilitators, for their child's learning, and learn as they go. Not that they have to know exactly all the new methods on how we're teaching multiplication, but maybe to learn that as we're going through, when we're using arrays, how that's, that helps kids in grade 10 solve polynomials. And making those kind of connections really makes it relevant for everybody. If you have questions along the way, feel free to just pop in and just ask a question. Okay. Okay, so how do we engage the parents? Well, I think in the school setting, it really does start with the administrator. You really need to create that culture where the administrator is the one to help build those relationships, provide the supports. And if I had more money, I would be able to do a lot of things with my own staff to build that confidence, increase their knowledge. And I would say right now, and that's the nice thing about now being a principal, is that you have a little bit more control in terms of money than I did as an instructional leader. But, I use a lot of my funds for PD to be able to build their confidence in math. So it really starts with that. And, we do family nights, and as an IL, I used to do a lot of family nights, and kids were there, everyone's having fun. But I always walked away with our family nights feeling that it's a fun event, but there was no long-term effect that happened with that. And what I really wanted to show was, what is it that we can do to help the parents really understand? So I started to run parent-only nights. And by having the parent-only nights, the kids weren't there. It was an opportunity for parents to ask questions. Parents even don't feel confident in their teaching. And they're afraid, and there's a lot of videos right now with the online learning that parents are afraid that kids actually will see that their parents don't know the math. So that's part of what we wanted to do with this parent only night. And I would always involve the staff as well there. And having the staff there, they can see what the vision of what my vision of math was for our community, so that they can kind of see, and I'm basically modeling the kind of questions that we want to see in the classroom, the kinds of questions, they get to see the kinds of questions that their parents also see as well. And my role as administrator is to support the staff. And once the parents understand what we're trying to do, then they could also support the staff as well by helping their child at home, making sure that homework is complete, making sure that they know when their kids are struggling and when they're not. Those are the kinds of supports that parents can provide also for the staff. Okay. I'm just going to take a break there and see if there's any questions. I happen to lose my chat, so I don't see the chat, but
Nothing yet, Caroline.
okay, great. All right, Charles, just let me know if there's anything there. Okay. So what do these parent math nights look like? I've done a couple of them for, I'm at Owen Public School right now, and I've also helped out a few colleagues. And as an IL, I used to do these as well. And I found that these were really helpful because it really gave an opportunity for me to do a little bit of higher level math. And it's not what they expect when they first come. They all think that I'm just going to teach them all the kind of rules on how their children can be better at math. But, what I'm going to do right now is I'm just going to kind of go through just kind of a quick overview of a workshop that I would do with parents. So I love games. I had done some work with Think Fun at one point on just kind of bridging games and problem solving with math. So I'd have lots of these games that would be out on the tables, and it really to try to capture them and engage the parents. And then they become interested, and then they want to get them for birthdays and gifts and things like that. So why not bring some of these things home that would really build the problem solving skills? So they get to play with those, which is great. And it's really about exposure, and that's part of my role is to help expose the mathematics to the parent community, to students, and to teachers. And then we talk about attitudes, and we talk about attitudes because this is really, I'd say, one of the fundamental reasons why there's conflict, and it's difficult sometimes for parents to really understand and know what we mean by our math curriculum. And to get out of that notion of just a single answer. We want all the answers to be right, but there's benefit to having wrong answers as well. And that's what we wanted to show. And then after we talk about these attitudes, to look at some key things. And I decided that I wanted to focus on computational skills because in elementary, that's the biggest conflict, I would say. And I wanted them to see that there were different types of questions that we can ask, maybe questions that they have never been exposed to before. And then I always get the question about, the difference between a level 3 and a level 4. And I'm not going to really focus so much on that for here, but that ends up being more of a reporting kind of question, but it matters to the students. So Christoph, I'm not sure if we can maybe unmute everyone just for this activity, because it really makes a difference when we kind of say it out loud. But some of you might be able to see this. Great. Okay. So what I'm going to do is I'm just going to ask you to add a series of numbers, and every time we do it, I'm going to ask you to say it out loud. Okay. So adding the word numbers, 1,040 is
1,040.
1,040 plus 1,000
2,040.
plus 30,
2,070.
and we're going to go a little faster. Okay, plus 1,000
3,070.
plus 20
3,090.
plus 1,000
4,090.
90.
plus 10
5,000.
Oh, it's 4,100.
Okay, thank you. Thanks, Christoph. So this was really interesting, and I love doing this. And someone had said, oh, sorry. Okay, am I still muted?
No, we can hear you.
Oh, okay, great. Okay, great.
Oh, I see the answers and I'm
Yeah. So it's really interesting. And I love doing this with parents, because when it comes to computation, and we're natural, it's natural for us to follow patterns. And, we go through and we follow patterns, and many had said five, in our group, I did hear 5,000. But, when you go to a large group, you do hear quite a few that say 5,000. And part of it is because we're just following a pattern naturally. But, then we talk about, okay, well, then why did we say 5,000? And that's just an interesting question. So then I pose that question, and then I have the parents go through, and then they start adding and they start doing, and then they realize that really has to do with place value. And making this mistake was actually really good. It was good because then we got to see, okay, well, this is what we do. And so part of the reason why, and the main reason why we end up doing these parent-only sessions, is because we want them to experience the math. Doing a curriculum night where we explain this is what the curriculum does, that's great. It gives them a good overview, but to really internalize it, they have to experience what their kids are going through. And about, what went wrong? Why is it that they got that answer? And it really opens the eyes of parents when they start to see, okay, maybe there is value to showing kids different ways. And so, as we go through some of them, we actually have them go through some activities at that time as well, and then have discussions among themselves and staff as well too. They get to see, that there is value in making mistakes, and as long as we're having discussions about, what happened when these mistakes are being done. So taking that risk, and I think that's one of the biggest problems that we have too, is that we don't have kids taking that risk, or even parents taking that risk, and there's too much emphasis on that one single right answer. And I remember my daughter, my middle child, she would always, leave. She always didn't do very well, or it took a long time for her to be able to get things. And it was interesting because it wasn't until about grade 2 when we realized, and I just asked the teacher, like, I don't understand why it's taking her so long. And we found out that she wouldn't write anything down until she knew that she had the right answer. And she wouldn't even try. She wouldn't even, try different routes or anything. So once we took that time restriction off of her, then she started to take that risk. And then it wasn't until maybe about grade 8 when she started to feel comfortable doing that. And now she's doing French immersion physics at U Ottawa. And we always go back to her experience when she was younger. And, I asked her, like, what made you make that change and start to take that risk? And she said, people started to actually pay attention to what was happening with my learning. And that made a big difference. And, even us as parents who are educators, sometimes, it's hard for us to even understand as well what's going on with our own children's minds. So one of the things I like to do with parents when we're doing these sessions is to really focus on problem solving. So that's the beauty of this, is that, you know, when we talk about the, you know, math processes, there are different things that we can do. And I always like doing live math, life-size math. So I would have, you know, elastics, and I would get 6 volunteers, and I would have the Hawaiian lays in, so that I've got green frogs and yellow frogs, and then we would have lily pads on the floor. And their goal, and many of you may know the frog games, the game frogs, and have all the yellow ones on one side go to the other side, and then the green ones go to the other side. And the only way they can move is they can move to an empty lily pod, or they can jump over one other frog of the opposite side. And, you know, sometimes, you know, people ask, well, why do you show this? Because the math is actually quite complex, and it is. It is definitely not up to, not elementary math, at least grade 5, up to grade 5. But the value in showing what happens when we get stuck on a problem. What do we do? What do we notice? And that's where we help build that risk taking. So having the students or the parents actually go through this, you know, I'll have them go, and then when they get stuck, I'll say, okay, freeze. What do you notice about the patterns? And eventually someone will say, well, when at the beginning, when you see 2 frogs that are side by side, then you know you're going to get stuck. And that's a huge step in terms of, you know, getting people in general to be able to reflect on their own thinking, see where they get stuck, and then go from there. And then I say, okay, well, you know, what happens if we add another lily pad to each side? So when we add another lily pad, we add more people, but then they notice that, you know, they're using the same process to be able to solve it, you know, which ends up being recursive. So, you know, without being so technical about it, they kind of understand this process, and then I get to kind of squeeze in that whole notion of problem solving and what do we do when we get stuck within this kind of lesson for them. Other ones that I like to also look at and really kind of focus on, you know, what happens when we make mistakes, or to look at patterns, is the Stoplight challenge. And this is very similar to, I think it's called Mastermind, back in the day when I was little, and we had those little colored pegs, and you had to create a code, and then the other person had to guess what the code was. And this one just here uses numbers, and it was a really great fun activity for the kids. But I do it with the parents, and part of why I do that is because I want them to be able to really talk about you know, what is actually happening. So if you look down here under the example, so if the number is 269 and then they guess, you know, 571, well, then if it's wrong, let me just go back. So if it's red or R, then no digits are correct. If it's yellow, then one of the digits is correct, but not in the right place. And if it's green, then the digits are correct and it's in the right position. And really what I wanted them to focus on was really this pattern here as to what is actually happening, right? So when we start to look at this here, how can we use logic and reasoning to be able to figure out and make educated guesses? And that's really where our goal is like, how do you make these educated guesses? And, you know, the parents find it really interesting, and they're amazed that they can start to look at these patterns and actually make better guesses. Okay. So that, you know, it's not just about teaching now in one way, but that there are many other strategies and routes that we can get to. And
so on that point, Caroline, there's a conversation or discussion that's been going on as a reaction to the video clip you showed earlier.
Yes.
And I think it's also tying in quite a bit with this idea of making mistakes. One of the comments was, you know, that the video also shows how multiple methods does not lead to a correct solution. Is this a confirmation bias? And there's been a couple of responses to that, For example, so it means that not all methods would lead to the correct solution. There's a bit of a back and forth here going on in the chat, and I was wondering if you might want to speak to this.
So I think part of it is that, like, this I wouldn't consider a method in terms of teaching multiplication. We would have other methods to teach multiplication. We might use blocks, we might use arrays, we might use number lines. So those are kind of different tools that we would use for multiplication. What I like about this clip is, well, it's really more about common errors. So when we start to look at common errors, like how is it that kids get these errors? And if I'm giving, if I'm giving a question and I see that, let's say, a third of the students have the same answer, well, that means they're thinking in some similar way, right? And part of what I can do as a teacher is to try to understand what they're thinking. And if I understand, and if they're thinking, let's say these students are thinking the way that they are in this video, then in that case, that would be helpful to me as a teacher, because then I know, okay, they're not really understanding that place value. So then I can target my teaching and do maybe a mini lesson on that, or maybe use a different tool that might better help understand that. Okay, so hopefully that helps. But again, and I'm not sure if you're able to, but if you do have a question, feel free to unmute and go ahead to ask the question. Okay, great. Okay. So, again, what we want to do is kind of establish that deeper understanding. If we go back to just the algorithm, and algorithms are great. And, one of the things I always say is that in probably, 80% of what we have to calculate on a day-to-day basis, there are other methods that we can use. We can break down into smaller numbers. There are other methods that we can use to be able to calculate. But if I have some obscure number, then the standard algorithm will work. So they still need to know that. I'm not dismissing the fact that they don't need to know the standard algorithms. But what we want to move away from is even parents understanding that there are more ways. If your kids are having trouble with the one standard algorithm, and that's what's holding them back, then why not show them other ways to be able to get there, right? So those are the kinds of discussions that we want to have. And when parents start to see that there are different ways, then they're a little bit more understanding in terms of what we're doing. So, again, there are a lot of parents who are saying, who from what I hear, like are busy. They don't have time to understand the curriculum, or nor do they even want to. They just want to know that their kids get good grades. And part of what we do is having these parent sessions is to get them to understand, okay, yes, you don't need to read the whole curriculum, but we want you to understand what our goals are in terms of what math should look like. Okay. And then this also helps them understand that when you get questions that don't look like the questions that you might be familiar with, these are the reasons why. We want them to be able to make connections. We want them to be able to represent the math in different ways. We want them to even know, what tools, what formulas, like what are the things that they need to know to be able to solve that. Okay. And then also the connecting, like the context, and sometimes it's hard, like the context might not be a real life context. It might be just something that's really amazing and beautiful. And when we're looking at soap bubbles, for example, and making a square soap bubble, like why does that happen? Those are interesting questions that we want our parents and our students to find interesting too. Okay, so it is all about the questions, I think, that we ask in the classroom and to our students. So when we look at this example, and I do like using this one because I'll just ask parents, so how many fish do you see? And then they all give the right answer, which is great. But then when I have them share with each other what are the different ways that you added this, then it was really interesting to see. And I'm amazed at how many people say, oh yeah, I didn't think of it this way. You know, some may have, you know, just added, you know, the 4 rows. Some might have taken this triangle and doubled it with this triangle and then added these 4s. And there's some that would just add it one at a time. Okay, and there's lots of different ways. So it's interesting to see what their thinking is as well. And part of that is, you know, when I say, well, if a teacher just expected one way, then should the other ones be dismissed? And, you know, this is where they start to see, okay, you know what, there is value in trying to figure out another way. Because if I get stuck on a problem and I don't know how to do it my normal way that I do it, the more that I have in my toolbox, then the more entry points I have to be able to solve a problem. Will I end up going back to an algorithm? Possibly. That might be one way. Or maybe using my other methods might help estimate it so that I have an idea of what the answers are going to be. And then as I build my computational skills, the algorithms and so on, that will help me fine tune it to get the exact answer that I want. Again, I had talked about arrays and just, you know, using multiplication, which many of our students have seen this. What I like to do is to just break it down for the parents so they understand what this looks like, and then tie it in to algebra. So, you know, change the 10 times the 10 and the 2 to, you know, x plus 6. And, you know, times, you know, x minus 3. And then use the same kind of, you know, model to be able to explain that. And they're amazed at, you know, the connections. And I think this is where, you know, part of the things that we need to do as educators is try to build those connections. But, you know, it goes back to someone in elementary, if they don't have that math background or haven't done a lot of PD, because a lot of PD does include a lot of connections, if they don't have that, then how do we build those? Because I think that's really a key piece that's that we need to continue to work on. And again, this goes back to the what's wrong. And this resource, I still love, Roads to Reasoning. This chapter focuses on questions where they give a problem, they give an incorrect solution, and then the students have to explain what's wrong with that. And it's much more difficult. And the kids who, you know, parents typically see as, you know, A+ students who are used to, you know, just doing calculations and computations, find this a struggle at the beginning. And then once they start to get better at it, then they start to see what the value is. Same with multiple choice questions. I remember when I worked at EQAO, creating multiple choice questions were probably harder than doing the others, because you really had to look at the distractors. And the distractors tend to be, you know, common errors, and you know, giving them the answer and say, okay, the answer is 36. What's wrong with A, B, and D? That's harder, right? And you know, going through this with teachers and with parents to see, can they figure out what the common errors are and how these other numbers came up? And that's a really great exercise for everyone to do, and for students to be able to try as well. And it makes it difficult. And this is where we're talking about the questioning. We can give questions that are a little bit more straightforward, or we could really, you know, have them dig really deep and try to figure out, you know, something else. Someone who can explain, you know, the other distractors really has a good understanding of this problem. Okay. And then math strings, also looking at, you know, different ways to be able to solve problems. We know that we can teach the standard algorithm, but we also know that, you know, what we can do is we can look at, if we want to, let's say, find out what 10 times 4 is, and we know that 10s are, but, you know, 10 times 4 is also 4 times 4 plus 6 times 4. breaking down these numbers and kind of to show that these are building blocks of the other numbers really helps them understand, and then they can carry it on to fractions or decimals and so on. So these are the kinds of things that when we're explaining to parents that, you know, when we're doing these kinds of things, they're not just random numbers, and it's not like the mad minute. You know, the mad minute, I remember that would stress me out completely. And you know, and it really, you know, for a lot of kids turns them off from math, and that's where you start to get that math anxiety. Does it help? Yes, it does help if they know their times tables and so on. But I remember even just spending a lot of time, you know, in the car with my kids, just breaking down numbers. And you know, if we're going from one point to another point, then I might as well, you know, as a parent, might as well, you know, ask them these things. And now it's just habit for them to be able to do it. So I used to always tell parents, you know, it's not the facts that we want them to memorize, but, you know, more of the strategies, right? If they can memorize strategies, then they could figure out a lot of things more than just memorizing the facts. Okay. And then it goes to, again, like, you know, what kinds of questions can we ask? And even at the kindergarten grade 1 level, sometimes, you know, we don't give kids, you know, enough credit in terms of what they can know. And it's beyond just recognizing numbers or being able to count to 10. But, you know, we want them to be able to look at different ways, and how can we ask the questions to really, you know, push their thinking. And, you know, for parents, like, you know, we're also looking at, yes, they can have the right answer. And in this case here, you know, the level 3 has the right answer, but the level 4, you know, has an answer presented in a way that they can check to see whether or not they've exhausted all the possibilities. And that's kind of the difference. And that's where we want to push kids. And we can do this, you know, from kindergarten on, and, you know, even younger. But, you know, these are the kinds of things that we also want our parents to kind of understand why, you know, even though they might have a right answer, why it is that we want to even push their thinking to develop other strategies in a more, you know, concise and systematic way. Okay. And again, and this is just a junior level, and it goes back to relationships and connections. And, you know, we can always give them, you know, the length and the width of things, right? But, you know, what happens to that perimeter and area when we start changing some numbers? And, you know, it's not an easy question for parents sometimes. And they start to see, and when I always ask them, would you rather have your child understand this kind of question or this kind of question? They all say that their kids would know more if they understand this. So, you know, part of it is, again, you know, a teacher could give the parents this kind of question, but when it comes down to it, they really don't understand what it is. Having the parents sit there and have this discussion really is what makes a difference, I feel, in terms of having them understand what our goals are. And then we go and we have hands-on experiences. And usually what I do is I divide them up by grade division. So I usually have a kindergarten table, and then, you know, primary, junior, and intermediate. And so that they can see the level and types of questions that they have. They can see the kinds of tools that we actually use in school to be able to do that. In my case, we do a lot of fundraising as well. So from the parents. And when they understand that we're integrating, you know, hands-on manipulatives, when we're integrating technology, I do a lot of technology in our school as well, related to math. So when they see the value of it and what we're doing in the classroom, then they can understand why we want some funds dedicated to this as well. This is also an opportunity for teachers to be in those areas, so they could hear the questions that the parents have. They can talk to the parents about it. And the nice thing is that not all the teachers really may understand you know, what the kind of questions that I was asking, but they're all learning together, and it kind of breaks down those barriers, which to me builds that relationship, as I think Amy had said earlier, between the teachers and the parents. So, you know, then we get into a little bit of assessment. And as I mentioned, I do feel that as a system, we still need to try to bridge the assessment practices between elementary and secondary, because I think that it's a difficult task to do. But that would make things a little bit easier, I think, to bridge from elementary to secondary. And then again, you know, when we talk about the research, you know, there are parents who are really interested in the research, and then there are parents who don't really care. So I am very careful in terms of the kind of research that I incorporate. I try to always link it to something that we're doing. In this case here, because we do a lot of congresses and band shows at our school, we and a lot of math discussions. So we do talk a lot about similarities and differences, and summarizing, and really making that an important part of how parents can help, because they don't need to know necessarily the topics, but they can ask their child to summarize it to them, or they can ask their child to identify, well, what's similar between these solutions, or what's different between these solutions. So having them involved in that kind of discussion, that's probably the best thing that parents can do. And they don't need to know, you know, everything in terms of the content. They don't need to know the specifics. What we're hoping is that if their child is able to explain it to them, then the parents will know the specifics in a better way, because their child had just taught it to them. Okay. And you know, then the parents understand that it's more than just procedure. It's, you know, it is also more about, you know, what it is and how and why we need to know this. Okay, and then we just go into assessment and what can they do at home. And again, like just some strategies for parents to help, because some of them just don't know, if they're a very busy household, you know, helping them understand. And I think that's the difference between my role as an IL and my role as administrator, is that I'm much more connected to the students and the families, and I see the baggage that comes with them, and I could see, you know, how difficult sometimes it is. So trying to at least show them that I understand, and providing them some ways that they could help their child is helpful as well. And then also just, you know, the toolkit and what kind of questions, and usually we'll provide some questions that they can ask, which are very generic kind of questions, but it'll help the child teach it to the parents, right? And then again, just talking about games and the value of the problem solving and the communication. And even the games are excellent for risk taking. So just having the kids take that risk. And then field trips, you know, just what are some things that you can do besides like even just going for a nature walk and going for a hike and taking photos and seeing where the math is. There's some really, you know, amazing field trips that they can do. And if they're going to be spending a summer, you know, going to New York or going to Boston, then, you know, here's some other things that you can see. And our science center is an amazing place and is filled, you know, with lots of things there. And, you know, and making family math part of their family culture and their goals and what they can do. So these are all the things that, you know, we want. So this is why I feel that, you know, we really need to engage parents, and we need to be able to communicate and talk to them. Family nights are great, but we need opportunities to be able to, you know, engage parents. And one of the suggestions that we had, that our focus this year was actually math at my school. And one of the things that they wanted to do was to have more parent sessions spread out and at different times to try to capture more of our parents involved. So I am going to ask, and maybe if maybe what I'll do is I'll put this in the chat as well, is I just use Jamboard, which is kind of like a whiteboard, which is great sometimes for feedback, but there are a couple of questions that you can see there. Let me just kind of pull it up a little bit. It looks like this. Oh, actually, I don't think you can see it right now. Christoph, do you see my Jamboard?
I think so.
Okay, it has a pink post-it.
Yes.
Okay, excellent, great, thanks. Okay, so on that link, I just have 3 questions, and this is one way that I sometimes like to use to get feedback. Just on the bottom, you will see, sorry, on the left-hand side, you will see the sticky note here, and you can choose different colors. The green ones are just what do you think would be helpful to help parents help their child in learning math. And the second, the blue ones, what do you see are challenges and barriers for parents at home that might hinder their ability to help their kids with math? And just any other comments or suggestions around helping parents that if you'd like to contribute to that. So I'm going to go back to, let's see.
So Caroline, I think I'm getting an error when I'm entering the link. It's, yeah, I tried typing it out. So maybe try copying the Jamboard link directly from the browser.
I'll do that.
The Bitly link didn't seem to work.
Okay, so thank you, and I'm happy to answer any questions. And then I'll try to put that link on.
Okay, so I've collected a couple of the questions that have come through in the chat, and some of the elements that have garnered a little bit more reaction. If there's any other questions, though, please feel free to throw them into the group chat. And just whenever you're ready, Caroline, I'll give you the first question.
Yeah. Yeah, you could go ahead.
Okay, so there was one person here who asked whether what a family parent math night could look like in secondary, and was asking for any success stories. And we had a Jeff Irvine who chimed in. I think it was Jeff Irvine who chimed in regarding his own experiences and in doing this for the different grade levels. And is this something that you'd want to speak to as well from your own experience?
Yeah, I haven't had I haven't worked with secondary parents. I think part of it is even as an IL, it's a little bit harder to get into the secondary schools. Most of my work with secondary was working with teachers on technology and how to integrate that into their math programming. But I could see, you know, even still having questions, and I think the teachers have to be confident. One of my friends who is a secondary principal likes to be involved, and her background is in math, in math as well. And part of what she wants to do is also just have groups. Part of it is with secondary, it's a little bit different in terms of there is a focus on grade 12. They don't tend to have a lot of parents that come unless it's parent night for report cards and it's about their child. So it would be interesting to see even just having, and I would even say that they probably have more success at secondary by opening it up even just for grade 9s and starting that there, because grade 9s, I think parents are still trying to figure out, what secondary is. So they have a lot of questions. So I could see them still trying to do that. Okay, I see that. What I'm going to do is I'm going to actually just send the link to, let's see if this works. Just as I could. Okay, so I'm just going to not use the shortcut, and then try that, see if that works. Okay.
It seems like it's the same issue. It could be a sharing issue.
Yeah, it says that it's available to everybody, but what I can do, Charles, is I could take a look at it later, and then I could try to see if I can fix it, and that could be sent out to everybody.
Yeah, absolutely. We'll do that. Another big point that I think has come up here in I guess the back channel discussion is the games aspect and how that plays into what you're doing with the math nights with parents. So Keith Devlin has been mentioned. You know, is there anything in particular you'd want to highlight? Maybe some specific games that have really worked well.
Are the questions about pick what appeals? I think it's really important to choose the games and have a purpose for whatever the games are. I think there are lots of things that that you could include that maybe aren't as relevant. Part of the ones that I chose were really about problem solving and the logical reasoning. So having those at the tables, we may have some games that are a little bit more math specific. And if we're doing some data management things, there are some specific games that we actually have that the kids do that the parents can do as well. But yeah, absolutely. Like, I think, and sometimes parents don't understand, why, but part of why we talk about, and I get that question, like, why do we do frogs, right? And then at the beginning, afterwards, when they start to see what the philosophy is of what I'm trying to kind of share with them, then they start to see the value in it. But I think when you choose games for your sessions, they have to be purposeful and connected to something, whether it's a strategy or whether it's an actual content. If I were doing this for, grade 12 frogs, then I'd start to look at the actual mathematics and algorithms of, the most efficient solutions, the least amount of steps, things like that.
There's a question, I guess, hot on the heels of that from Pamela. Do you find you have to really explain to parents the value of games in math? And do many of them still default back to worksheets and the ways they learned?
Yeah, I think it also depends on the teacher, and I think it was Michael who had said that it comes down to the teacher. I think that's true. I think the administrator sets the tone. Two, depending on the teacher that you have and their experience, right? So my school happens to be a dual track school, and I would say, French immersion tends to be a little bit more traditional, and I see it now, especially now that we're online, and I see, the teachers who are used to handouts are still providing PDFs, and the biggest complaint that I get is my child can't edit the PDF. So that's really, and so I ask them, well, why are you sending PDFs, right? And those are the things that takes time. You have to, you really have to, I think that's my role as a coach, is to try to help them change. I do get parents who still want those worksheets, and for me, part of it is still to bridge that communication between the teacher and the parent, and setting a tone where I have teachers go in and collaborate. I'm really lucky that my school's an open area, so I've timetabled it in such a way that there's co-teaching happening all the time. And, at first they're uncomfortable, but then they see that it's really easier to be able to teach that way. And then parents start to understand that, okay, it's more than just the worksheets. So it does help. Again, I would say the games is not really what changes things. It's the questioning, right? It's the kind of questions. If they're not playing games, but they're asking those higher level questions, I'd be way happier. And, you know, one of the research I showed before, I remember, you know, you have teachers who are trying to shift into, you know, new ways of teaching, but they don't really understand the philosophy really behind it. And those are the ones that don't do well. The ones that do better are the ones that have that understanding and they make those changes. The ones who do better after that are the ones who teach rotely, and you know, and the kids do well because they've memorized things. But the ones who try to make the shift using these other methods, but don't really understand those methods, they do crash. So part of what we need to do is build that culture in our school of collaboration and helping one another and moving teachers, you know, step at a time to be able to, you know, to gain that understanding.
Another question here from Michael. So have you found any challenges with regards to English language learners, whether it's the parent or the family?
Yeah, so, you know, my school actually has a lot of international students that are coming in from other countries. We have delegates who have kids that are, you know, ambassadors who have their kids in international schools all over the world. And, you know, it's always a shock at the beginning. And, you know, I always ask them to talk to the teachers about programming, and if they have more questions, come to me. And, you know, when we have that discussion and then we explain these things, then they usually have a better understanding of it. It really is about that relationship that we have with our parent community. But, you know, again, when we're looking just in general, ESL, spec ed, we have a lot of kids that are on the spectrum as well. You know, it's still learning different ways to be able to make math meaningful to them. So I have an amazing support staff, and then the way I timetable it is I have them doing a lot of co-teaching there, and a lot of them benefit from things like congresses, and in fact they do better. They just might not have the technical skills, but they can still reason and communicate their ideas in some way.
All right. Well, thank you so much, Caroline, for speaking to this subject. I think it's